chemistry, I think of explosions and love and mixing things together, but chemistry is really about stuff. Chemistry attempts to answer questions about stuff like, what is stuff? What can stuff do? How does stuff happen? And how does stuff interact with other stuff? Now, a better word for stuff is matter. That's anything that has mass and volume. So let's make sure we know what mass and volume are. Mass is the amount of matter an object contains. We can measure mass with an electronic or an analog balance. Okay, technically, that's measuring weight, which is actually gravity's pull on mass, but it's the quickest way to measure mass on planet Earth, which, by the way, is where most people do chemistry. Volume is a measure of the space occupied by the object. You can measure volume of a regular-shaped solid object using math. But for irregular solid objects, water displacement is an easier method. Matter can be divided into two basic categories: substances and mixtures of those substances. Substances are often referred to as pure substances because they have a uniform and definite composition. For example, this copper kettle is mostly made of copper. A copper kettle and a copper coin will have the same properties because they're made of the same substance. Water in this glass is also a pure substance. It's uniform and made of all of the same compound, H2O. Copper and gold are very similar to each other in that they're malleable, shiny metals that conduct electricity, but they have a few physical properties that help you tell them apart. A physical property is a quality or condition of a substance that can be observed or measured without change in its composition. For example, if you melt copper and gold, you'll see that copper melts at 2,562 degrees Celsius and gold melts at a higher temperature of 2,856 degrees Celsius. Melting is a physical change, not a chemical change, so melting point is a physical property. For each of the substances listed here, there are physical properties like the state at room temperature, color, melting point, and boiling point in degrees Celsius. So if you needed to tell the difference between, say, ethanol and water, which are both liquid and colorless, you could put them in the freezer, which is typically at negative 18 degrees Celsius or 0 degrees Fahrenheit. That's cold enough to freeze water, but not cold enough to freeze ethanol. If it freezes, it's water. If it doesn't freeze, it's ethanol. And speaking of freezing, we should review the states of matter to help us understand physical properties a little better. There are 3 states of matter that we're going to look at: solids, liquids, and gases. Oh, and kudos, yeah, there's one more that I forgot, but I didn't forget it: plasma. But that's for another time. Solids have a definite shape and volume. This means that no matter what container you put the solid in, the solid will maintain its original shape. The particles that make up solids are tightly packed together with just a little bit of movement in the particles. Solids are also incompressible because the particles are already so tightly packed together. A liquid has an indefinite shape, can flow, but has a fixed volume. Because liquids can flow, they fill the shape of their container but maintain the same volume. The particles of a liquid move faster than those of a solid, and there is some space between the particles. This bit of empty space between particles means that liquids are very, very, very slightly compressible, but if you add heat, the liquid will expand slightly from the increased movement of the particles. Gases are the crazy particles. They have a much higher energy and are spaced farther apart, and can therefore take the shape and volume of its container. This means that a gas can fill any volume, and it can also be compressed to a smaller volume. The word gas and the word vapor are sometimes used interchangeably, but there is a difference. Gases are gases at room temperature, and a vapor is when something that is normally a solid or a liquid at room temperature has become a gas. So when water evaporates, it becomes water vapor, not water gas. The process of water evaporating is considered a physical change because the molecules haven't rearranged themselves. They're just moving so fast that they can change from one state of matter to another. A physical change is when some physical properties of the material change, but the composition of the material does not change. Certain words can clue you into a physical change, like boil, melt, freeze, crush, condense, split, cut, and grind. All of these are physical, not chemical changes. Also, some of these changes are reversible and some are irreversible. Melting ice, freezing water, and condensing water vapor are examples of reversible physical change. You can change them back by changing the temperature. Cracking an egg, cutting your hair, and sharpening a pencil are irreversible. You can't uncut your hair. If that were possible, that would actually be seriously cool, but kind of weird. And also, it's not possible. It's irreversible. Now let's back up a little and go back to the part where we split matter into two categories. It's time to look at mixtures in a little more depth. Mixtures are physical blends of two or more components. Mixtures can be homogeneous or heterogeneous. Homo means same, so homogeneous mixtures are uniform and smooth throughout, like air, steel, or milk. Hetero means different, so heterogeneous mixtures are not uniform. In fact, they might be spotted or chunky like this granite, or hardly even mixed at all like oil and water in salad dressing. Homogeneous mixtures have one phase, meaning you can only see one thing. Heterogeneous mixtures have two or more phases, meaning there are more things you can see in the mixture. It is possible to separate mixtures by utilizing differences in physical properties. There are tons of different ways to separate, like using magnets on certain metals, filtration through fine paper to get grit out of a solution, evaporation to boil off water, distillation to separate two liquids, chromatography to separate dyes, flotation to capture substances that can float, centrifuge to collect denser substances, and sieves of mesh for sifting larger objects. Let's look at filtration and distillation a little closer. Filtration is a process that separates a solid from a liquid in a heterogeneous mixture. You need a container with a filter, like a pasta strainer or a funnel with filter paper. And you need a collecting vessel like a bowl, beaker, or a flask. You could use this to separate spaghetti and water, or sand and water, or any other solid and liquid. Distillation is a process to separate two liquids where liquid is boiled to produce vapor, which is then condensed and collected. This is how alcohol is distilled to get a purer form. Alcohol boils at a lower temperature than water, so the mixture is heated so that the alcohol vaporizes, but not the water. Then the alcohol condenses through a special condenser tube that keeps cool by running water through it. And then the alcohol is collected at the end of the tube. Now you know one of the steps for making moonshine. Not that you would ever do that. I mean, that would be kind of ridiculous. Let's go back to substances for a moment. It turns out that pure substances can also be divided into two categories: elements and compounds. Elements are the simplest form of matter that has a unique set of properties. Elements can be made of single atoms or molecules of the same element bonded to themselves. Compounds are substances that contain two or more elements which are chemically combined in a fixed proportion. Here are molecules of water, which are made of 2 hydrogen atoms and 1 oxygen atom. You can also have mixtures of elements and compounds. This picture represents a mixture of 2 different elements and a compound. You can break compounds down into elements through chemical change. This is a change that produces matter with a different composition than the original matter. The atoms get rearranged. For example, the sugar in this bread was burned, which caused a chemical change that broke the sugar down into black carbon and water. The sugar started white and sweet and broke down into this unsweet carbon and tasteless water vapor. This helps us to see that the properties of compounds are different from their component elements. For example, sodium is a highly explosive chemical in water. Chlorine gas is toxic and can kill you, but they combine to make sodium chloride, which is table salt. Not only is it safe, it's delicious. So let's put this all together in a matter flowchart. Matter can be divided into substances and mixtures. Substances can be divided into elements and compounds. Mixtures can be divided into homogeneous and heterogeneous types. Also, mixtures can be physically separated into substances, and compounds can be chemically separated into elements. Thank you for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter @SciencePet.